Hello everyone, today we are beginning our 11th unit on 3D shapes. We'll begin with section 1 covering Introduction to 3D shapes, nets, and cross sections.
3D shapes in of themselves are figures that have 3 dimensions, length, width, and height. So previously we were working with 2-dimensional shapes, which would have just the length and the height maybe. Now we also have this width. It gives us some depth to our shape. Every 3D shape has different, each part of the 3D shape has a name. So we have the edge, which is where two faces come together. We have our faces, which are the flat surfaces of a figure. And we have the vertex, which is the point that all the faces come together at. All 3D shapes are categorized into different subgroups. A few that we're going to look at today involve prisms, pyramids, cylinders, and cones. When you're trying to name a prism, there's a few key things you need to look for. One of those things is that you have two end faces, also called bases, that are congruent and parallel. So just a reminder, congruent means same shape and size, and parallel means that they will never touch. They're directly across from each other. So you're looking for faces that are congruent and parallel, and you also need to have sides that are parallelograms. So all sides are parallelograms. And just a reminder, parallelograms are shapes where the opposite sides, opposite edges, are parallel. A good example would be a rectangle. All right, pyramids are very similar. What you're looking for, again, you need a base or a face. So you have one end face, not two, you have one. And the other thing that you want to look for is that all sides are lateral faces, and those lateral faces, or the side faces, however you want to put that, I'm going to use the word lateral. All lateral faces form a point. So you'll have one point, one base, and the point and the base should be across from each other, opposite from each other. All right, so those are the two big categories. If we're looking at our examples over here, I have two bases on this top, and the top one has this triangle there. For all prisms and pyramids, the shape of the base determines the name of the figure. So let's write that down here. Let's do it this way. The base shape determines figure name. So if the base shape determines the figure name, this first one has two bases and they are triangles. That means that the name of this prism is a triangular prism. And I know it's a prism because it has two bases. All right, the next one is a special case. It does technically fall in the prism category, but it is a cylinder. We know that because the two bases are circular, so we have a special name for that called cylinder. Then we're looking at pyramids. In pyramids, you're looking for that one end face or the base. In this case, it's a triangle. So I have, since one base, one point, and the base is a triangle, I have a triangular pyramid, which does have another name. You may have heard it called the tetrahedron. The tetrahedron. That's just another name, means the same thing. And then next we have a circular base with a point. That is always called a cone. So a cone has a circular base and a point, and it's technically a pyramid as well, but we call them cones. They're not, we don't say the cone pyramid, it's just a cone. All right, so let's go ahead and look at some examples and name these shapes. So as I'm looking at this first row of shapes, I notice that all of them have two bases, one on the top, one on the bottom. So all the things on the top row are all prisms. I want to look at the type of shape to determine what kind of prism. So this first one is very similar to what we did up above. It is a triangle on the base, so that means that this is called a triangular prism. As we look at the next one, it does tell me that all angles are 90-degree angles, and it looks pretty rectangular to me. But even if it was a square, we still would call it a rectangular prism because a square is a rectangle. So rectangular prism is what we want to use. The next shape, I need to count the sides here. I have 1, 2, 3, 4, 5. There are 5 sides, and it's in a regular pentagon shape. That is what we call a pentagonal prism. And this next one has 1, 2, 3, 4, 5, 6 sides. That's what we call a hexagon, which means that this is a hexagonal prism. All right, now let's look at the pyramids listed below. And I know they're all pyramids because they all have one base and one peak or one point. So they're all pyramids. This first one has a triangle for a base. It's just like what we did before. It's again a triangular pyramid. This next one, I can't really tell if it's a square or a rectangle, but I can tell that it has the 4 sides. And again, even if the bottom's a square, it technically falls in the category of a rectangular prism, or sorry, pyramid. The only thing I will mention about that is if it is a square, it will probably tell you, or it will give you the markings, and then you'll know right away that it is a square for sure. Next, we have 1, 2, 3, 4, 5 sides on the base. That means that we're again working with a pentagon, so this is a pentagonal pyramid. And last but not least, we have 1, 2, 3, 4, 5, 6 sides. That means the base is a hexagon, so we have a hexagonal pyramid. Let's fix our spelling here a second, or rather my handwriting. There we go. This example here is asking you to find the diagonal of a rectangular prism with length 12 centimeters, width 10 centimeters, and height 15 centimeters. So if I were to draw out a rectangular prism, and again, I'm going to do the best I can to get this shape here. It's not going to be exactly perfect, but bear with me. All right, so there's my rectangular prism. In the rectangular prism, the diagonal is not pictured. It's something that you have to imagine that is going from one point to the opposite point, right through the center of the shape. That diagonal is what they're asking for. In order to solve for the diagonal, what you have to do is you have to use this formula that says the diagonal is equal to the square root of the length squared plus the width squared plus the height squared. So it says that I have a length of 12, a width of 10, and a height of 15. So I'm going to go ahead and plug those things into my formula. D is equal to the square root of 12 squared plus 10 squared plus 15 squared. I'm going to jump ahead. When you square 12, you get 144. 10 squared is 100. 15 squared is 225. When you add all those numbers together, that gives you the square root of 469. When you take the square root of 469, that gives you a diagonal with about 21.66 centimeters in length. That is a general overview of the shapes themselves. Now that we've looked at names of three-dimensional figures, we're going to look at their outline, and that's something that we call a net. To be more specific, a net is a two-dimensional diagram of the surfaces of a 3D figure that can fold into the shape. So for example, if we look at the figure below, if we were to fold on the solid lines between each figure, we would end up with, there's one base with 1, 2, 3, 4 sides. We said this was the base. That leaves this last piece to fold over the top, so this is our second base. So what you're looking at, if we were to fold that up, and bear with me on my drawing skills here, they're not the greatest, we would end up with a cube, or what is technically a square prism, but we call those cubes. All right, so let's go ahead and look at some examples. If we look at this first picture here, as I am outlining this one shape that is highlighted in orange in the middle, that I know is a square, so I'm going to go ahead and write that it is a square something. That's my base. When I look at the sides, I notice that each side has a triangle that takes up the entire edge of the square, and it comes to a point, so that means that I'm working with a square pyramid. Or technically, I would also take the answer of rectangular pyramid, because it doesn't really label it as a square. I'm telling you it is a square, so it's a square pyramid, but I would take rectangular as well. All right, this next shape here, I have, let's see, 2 circles, and it looks like they're on opposite sides of the shape, so I'm going to call these my bases. If I have 2 circular bases, that means that I have to have a cylinder, because a cylinder has 2 circular bases. And if the rectangle in the middle is confusing you, that rectangle is going to fold up and curve around the circle. All right, let's go down to this shape here, the purple one here. This looks a little trickier. I have this one circle and I have a hemisphere, or well, it's not a three-dimensional figure, so that's not a hemisphere, that's just half a circle. But that is going to fold around the circle. So I'm going to call this my base, which means that this shape is a cone because I have one circle base. Last but not least, I have 1, 2, 3, 4, 5, 6 sides, and I have 2 of those shapes. And this one's in the center, so I know that for sure is a base. That means this other hexagon has to be a base as well. And I have 1, 2, 3, 4, 5, 6 parallelograms that are connecting on the edge, so that tells me right away that I have a prism. And because the base is a hexagon, this has to be a hexagonal prism. A cross-section is the intersection between a 3D figure and a flat plane. So it's specifically the intersection between the two shapes. So let's say you have some three-dimensional figure, such as, let's say you have a cup of water, and you were to take a paper and do a magic trick, and all of a sudden that paper, when you hit it on the cup, is right in the middle of the cup. The area that is covered by both the cup and the paper is the cross section. So in example 1 here, we have this shape. It is a Pentagonal Pyramid, and it has this paper that cuts through it, and outlined in red here, we have this shape that is created by slicing this paper right into our figure. That area that is covered by both objects, that is our cross section. That's what we're looking at here. The shape that I just outlined and colored, that is what we're naming. So when I look at that, I have 1, 2, 3, 4, 5 sides. That means it is a pentagon. So this cross section is called a pentagon. All right. So often you have going straight through the center. We'll do another problem like that, but the cross section, that paper doesn't have to cut through parallel to the ground. It can cut through in any direction, and we'll cover what that means as we go further down the page. But this next one here, we have a horizontal parallel to the ground paper going through a cone, and as it's cutting through, you kind of have to imagine what the cone looks like. As the cone comes to a point, it continues to be circular. Now my drawing kind of looks like an oval there, but it is meant to be a circle, so that cross section is a circle. All right, so now we get into a few of those other directions. So let's look at this cylinder, the cylinder here. This cylinder has a cut going straight down vertical through the shape. So picture canned vegetables. Let's say you have a can of green beans. If you were to take a knife, or probably something sharper than a knife, maybe a saw, and you were to saw right down the center of it to open that can, that is the shape that we're looking at. If we were to cut this and it was a solid, when you opened it up, what I picture is you'd have this shape here, and it would be rounded at the top. You'd see the inside there as well, but the main figure that you're looking at, if you were to look at it straight on, you would kind of have to not, you're going to have to visualize this, but you wouldn't actually see the top of the can or the bottom of it if it was solid. You would just see the shape that's remaining there, which happens to be a rectangle. So this cross section is actually a rectangle. Maybe that makes a lot of sense to you, but that is definitely the one that tripped me up the most when I was learning these. Here's another one going straight down, vertical to the ground, cutting through our cone. When it cuts our cone, same thing where you wouldn't see the top of the cone. So if you got like a sugar cone, ice cream cone, and you were to cut it straight down and look at it, if it was solid, what you would see is the flat bottom from our cut right here. Then you would see the peak that comes down like so. So the shape that you're left with there is a triangle. and you are getting that from our cross section. That one's a little easier to see as opposed to the cylinder. All right, so now we've had horizontal cuts and vertical cuts. The next two examples are what happens when you come at an angle. So if we start with this cube up here, and I'm noticing that I have this paper that's cutting off a corner. The first thing I want to think about, because I can see this base shape right there, the base is the intersection on this one. How many faces from our cube are being cut by this paper? Well, we have this face, we have the top, and we have the one over here that you can't see. That means that you only have 3 sides that it's cutting through. So this cut is cutting straight down like so. So the shape that is left in our cross section is a triangle. All right. Next we have this shape here. When I'm looking at this, first thing I want to think about is my three-dimensional figure. How many sides does this have? Well, I'm noticing that it's going straight back here and straight back there and straight across here. That means that I have to have a 4th side that's cutting straight across the back. So I for sure am working with 4 sides here. So this is a rectangular pyramid because it's coming to a peak. As I'm looking at this cross section, I know that I'm coming down on this angle on both sides. But think about a pyramid. It starts big and it grows, and as it grows, it gets smaller and comes to that peak. That means that this bottom part of my shape is actually going to be bigger than this piece up top because the piece on the top is at a smaller part of the pyramid. So the shape that we're looking with, and I'm going to exaggerate it a little bit from what you're seeing on the drawing, but you end up with this big side and this small side that's up above. And when you have a shape that looks like that, might not be super clear, might help if you rotate your paper a little bit, but that is actually a trapezoid. Has the 2 parallel sides and 2 sides that are connecting on an angle from the bottom base to the top base. All right, that covers horizontal cuts, vertical cuts, and angular cuts. Some of them are pretty clear, such as our pentagon from our first example. Some of them, like this one that we just did here, requires a little bit of thought. So I just caution you to be careful. Think about what that shape is doing and what it looks like, and it might be helpful to draw these pictures yourself when you're trying to figure out what shape this cross section is.
This is where we're going to end for today. We'll resume with section 2 covering surface area.